Alright, so here we're on lesson 106. As you can see, applied math, Ohm's law, electrical symbols, boxes, and box fill. Listen, that's a ton of stuff in one lesson here for sure. I'm actually going to break this intro up into two videos just because there's so much information here. But as you can see, we have to read the content in 106 as well as EWR chapter 2. So I'll do all the EWR stuff in a second video here. But yeah, this is the last time we really have a chapter that's kind of dedicated to math. I mean, it's always going to be there, but this is the last time we actually have to sort of focus on it. So moving through, you're going to see here a lot of geometry again. I'm hoping you guys are all well versed on this math and it's not going to create too many headaches. But if anybody needs to see anything more in depth, please contact me. But over here we get into something a little more exciting, and that's our Ohm's law. I think all of you have seen this and worked with this, and again, hopefully you're going to find this a breeze as well. So I won't bore you too much with these details here. But one thing that they mention here is contrast results of using different applied voltages and resistances as demonstrated in Ohm's law. So, you know, what they're talking about here is a pretty important concept, and I'm going to jump ahead a little bit, but you know, what effect does it have when we have something rated at one voltage, say 120, and we power it using a different voltage, say 130 volts instead? What happens to the watts and the amps comparatively? So I want to just show you this here. So again, finding fixed resistance using Ohm's law. I'm hoping this is familiar, but this is a very important concept here. So any piece of equipment is going to have rated values. So in this case, let's work with a piece of equipment is rated to run at 120 volts. If we run it at 120 volts, it'll put out 100 watts. What happens though if we run it at actually 130 volts? What effect does that have on our wattage ultimately? Okay, so how do you figure that out? Well, we're going to need to incorporate Ohm's law here, of course. So I want to find a term we call fixed resistance. Okay, the reason I want to do this, your resistance in any piece of equipment is it's inherent to it's a physical property to that device itself. So it's a heating element, a lamp filament. The resistance is a physical characteristic. No matter what we do, we can't change that resistance other than break it apart. So your resistance is quite literally fixed. So because of that, when we do these calculations, we're going to use all values that were either rated values or all the values that were actual values. The only value that's allowed to sort of cross this bridge and go in both columns, the rated or the actual column, is your resistance. Okay, and let's run through this, and I think that'll make a little more sense. So again, first off, we have to find resistance. Okay, how are we going to do that? Well, of course we know we're going to use Ohm's law for that, right? So again, I'm going to be quick about this. I'm going to assume you guys know your Ohm's law pretty well. So we know we're looking for resistance here. Again, find fixed resistance. So we know we're kind of relegated to this quadrant of the Ohm's law wheel for sure. And again, what values do we know? Well, we know volts, we know watts. So we're going to have to find a formula within that quadrant that contains both volts and watts. So of course, that's going to be our E squared divided by P. So we're looking for R. We know E, we know P, so we have to use E squared divided by P. We fill in the values, that would be 120 squared divided by 100, or to go ahead and solve that, 144 ohms. Okay, so what that's telling us is this device that's rated 120 volts, 100 watts, has a resistance of 144 ohms. Like I said, that's the only value that's allowed to cross from the rated value side to the actual value side. Okay, so now what's nice about that is we want to find what is the watt output if we power this at 130. Well, guess what? Now we have two values to work with, and as hopefully you know, or you will learn from doing this chapter, with any two values we can find the other two remaining values. So again, how do we do that? Well, guess what? Back to Ohm's law again, right? So we know P, or we know watts, so we need to find the formula that contains both volts and ohms within that same quadrant. Of course, that's going to be E squared divided by R. Okay, so 130 squared divided by 144 should give us our wattage. And we come out with 117.361. So of course that'll fill that answer in. Now I like to stop at this point and do a check. So one thing that's always going to be true for resistive loads, okay, I stress resistive loads. That doesn't apply to inductive loads, to motors, to fluorescent ballasts, but resistive loads. Anytime I raise the voltage, it's going to raise the watts, it's going to raise the amps. And just the opposite, if I lower the voltage, it'll lower the watts, lower the amps. So in this case, right? Let's do some comparison here. We actually increase the voltage, so guess what happens? Our wattage increases just a little bit as well. So that's just a nice little check there for you. Okay. So back to our text here. Again, there's a ton of stuff in Ohm's law. I'm going to insist you guys become comfortable with that and get good at that. And they're going to run you through several different problems here. And then you're going to see they start to get into different types of outlet boxes. I have no idea why they put these two things together, but they did. And as you're going to see, this is obviously a very visual section. There's just a ton of different options. So go ahead and read about that stuff. There's a ton of good stuff. I'm going to have also a video in here about an old work box or a cut-in box. That's kind of a difficult task to describe, but there's a lot of great videos of it, so I'll have a link to that in this chapter as well. But you can see then they're just kind of going through some various different boxes here. So next up, they do mention box fill. We're going to see that in the EWR book next, so that's going to be another big part of the chapter.